All right, so one of the most important things in figuring out a compound formula is knowing how many atoms of each element are in the compounds. So let's start with this one. We're going to take this compound formula Na2S2O3, and figure out how much is in each. So let me just write this down. Na2S2O3. I'm going to break it down into each of its elements. So there's sodium, there's sulfur, and there's oxygen. And this one's pretty straightforward. There's no trickery involved, but there's two sodiums. There are two sulfurs. You can see by the subscript here. And also there are three oxygens. All right, let's try something a little bit tougher. So we have magnesium and NO3, 2. So we'll break that thing down into its three parts. You have Mg, there's an N's and there's O's, and we need to figure out exactly how much is in each. Now, the subscript 2 is applying to the thing that's in the parentheses before it. So this subscript 2 does not apply to that magnesium over here. So there is only one magnesium that you can see. Now this NO3 with the subscript, or in parentheses with the subscript 2 in there, is saying that there's two NO3s. Basically, this is like having NO3 and another NO3. So as far as how many N's there are, there's actually two of them. One from here and one from there. And then as far as O's go, there's 6 of them. I would kind of think of it like that in that regard. There's a whole bunch of rules where you can say, well, if it's out here, then you multiply it and all of that kind of stuff. Just think of this as there's one magnesium with two of these NO3 compounds attached to it. All right, we'll try. So that was A. Here's B. And we'll try part C, or question C. I have 3 CaBr2. So essentially what that's saying is that that is the same as having CaBr2, CaBr2, CaBr2. Now this time, the 3 actually does apply to the Ca and the Br. If it were a 3, like for example in the previous one when I had the 2 that had a, was applying to the parentheses, it only applied to the thing that's in the parentheses here. But this 3 basically multiplies this whole compound. So as far as how many CAs I have and how many BRs I have 3 CAs. And as far as bromines, I have 6 of them. I guess one way you can look at it is you have the 3 times the 2, and that gives you the 6, whereas the 3 times the 1 will give you 3. Now we'll combine all of this kind of techniques, and we'll see what we got for part D. I have 2 Ba3 PO4 2. Okay. So I'm going to go through this one without, or I'm just going to talk my way through this one as much as I can because I've shown you the techniques. Let's see, what kind of elements do I have? I've got barium, phosphorus, and oxygen. Now, the barium, there's 3 barium, but remember, I'm multiplying it by 2 out in front, so there's actually 6 barium. As far as phosphorus goes, this 2 over here gets distributed to that phosphorus over there, so there's 2 phosphorus, but remember, I am multiplying this whole thing by 2, again the coefficient out in front, so there's actually 4 phosphoruses. And the oxygen, you might not think this, it's kind of hidden in there, but think about this, is there's 4 oxygens, but you're multiplying by that coefficient 2, and so that's 8 oxygen, but you're multiplying that by the coefficient out in front, and so then you have 16 oxygens. Knowing how many elements is in each is really going to become really important later on when we balance chemical equations and do stoichiometry and all of that kind of stuff.